Hi, welcome to Build Succeeded. My name is Lucian and this is the third video in the 3D Engine series, where we're going to do something really cool in my opinion, custom texturing. We're going to turn that bland solid cube into a textured crate. If you haven't seen the first two episodes of this series, I suggest you go back and watch them. We're going to continue from there. I've added the links in the description. Let's get to it. Let's enjoy a cold one while implementing this. This is what we have after the first two episodes, a solid cube rotating around. We're going to add a crate texture to it, but before doing that, we need to change the way we draw the triangles. As you can see in this piece of code, to draw triangles we're currently using the Direct2D Fill Geometry method. We're going to get rid of that, as we need more control over each triangle pixel in order to color it correctly according to the texture. We're going to implement triangle rasterization. One common method to rasterize triangles is to draw them line by line from top to bottom. Let's say we have to draw this triangle. We know the three corners. On the vertical axis, we start from the Y position of the top corner and go down line by line to the bottom corner. For each line, we calculate the start and end horizontal positions. Then, pixel by pixel, we draw it with a specific color. To make the calculations easy, we will split the triangle in two by cutting it horizontally through the middle point. Direct2D does not allow setting each pixel individually, and using the draw rectangle method to draw one by one pixel rectangles is extremely slow. So I'm going to do this differently. I'm going to build a bitmap in memory the same size as the resolution of the game. That will allow me to set individual pixels directly in memory. Then at the end, draw that image to the screen using Direct2D's draw bitmap method. So let's start by going to the engine base class and add a bitmap and an array of integers the size of the screen called render buffer. After the Direct2D initialization, I'm going to initialize the bitmap. After that, in the draw method, I'm making a couple of other small changes. I'm going to clear the memory of the render buffer variable where I'm going to draw, and after the triangles are drawn, I copy the render buffer into the bitmap and use draw bitmap to draw it on the screen. Now we need to teach the triangle to write into the integer array instead of directly in Direct2D. That means in the triangle class, I'm updating the draw method to receive the array instead of the render target. And you know what? We don't need this Direct2D brush anymore. Now the draw method. Let's remove everything we have so far. We have the 3 points, but not in the right order, so let's order them vertically first. Now we know the first one is the top one and the third one is the bottom one. First, the top part of the triangle, from the top to the middle point. If there is a vertical difference between them, I'm going to calculate the horizontal step for both lines of the triangle. Then, using this for loop to go through each horizontal line, I'm calculating x1 and x2 as the start and end horizontal positions for that line. Of course, if they are not in the right order, we switch them. Finally, going from x1 to x2, pixel by pixel, we can set the color of the pixel in the render buffer array. We are going to do exactly the same for the bottom part of the triangle. Now I can update the triangle's draw call in engine base to use the render buffer, then run the project. It looks exactly the same, which means we got it right, except for the FPS, which dropped from 4000 to 2500. Without the hardware acceleration, this was expected. Now, in order to texture the triangle, we need to decide what color each pixel will be, depending on where on the texture the pixel will fall. Let's say we have this image as a texture, and we want to texture a triangle like this one. We need to know where each corner of the triangle will fall on the texture. For example, this corner might end up here, this one might be here, and the last one here, which means this part of the texture needs to be drawn on the screen as the triangle. So we need to decide where on the texture each triangle pixel will fall. To be able to calculate that, we need more information about the triangle. Specifically, for each of the 3 corners, we need 2D coordinates on where on the texture that corner will be. We can call these U and V. To make calculations easier, we consider this corner of the texture to be 0, 0 and this one 1, 1. So any point inside the texture will fall between 0 and 1. I found this image of a crate on the internet. We're going to apply this to the cube. First, we need to add a way to load the image into memory. And that's what this new method does. Since it's not the scope of the video, I'll just say this method receives the name of the file and returns the bitmap of the file loaded into memory. Now I'll create a texture class to hold the information about each texture. The texture will have a width, a height, and the pointer in memory where the image itself will reside after loading. In the constructor of the texture class, I'm going to receive a bitmap object and I'm going to extract some information from it, like the width and height, and copy the pixels into my pointer. The destructor will delete the memory used, then a couple more useful methods, and finally a method to sample the color of the texture in a specific location. Now to store the texturing information, I will go to the point3D structure and add U and V, the coordinates inside the texture. Going back to engine base, I'll make sure I'll copy these over when transforming or projecting points. Now each triangle can have their own texture, so let's add a pointer to the texture on the triangle class. And on the cube class, in the constructor, I'll load the texture from the file. Then I will change the way I create the triangles for the cube to provide the texture coordinates for each corner and the texture pointer itself. Finally, in the draw method of the triangle, I'm going to use some custom integers to store the 3 triangle points for easier calculations. Let me quickly change where it's used. Let me extract the texture size, we'll use it a bit later. Now inside the first for loop where we calculate each line, I need to also calculate the start and end U and V coordinates for each line. Then we will make sure to swap them as well when we swap X coordinates. Now I'm adding a condition for the pixel by pixel loop to only go through if X1 and X2 are not the same. I'll calculate the step for U and V. Then inside I'll update U and V with this step. I'm using the steps so I do as little as possible inside the second loop to save CPU cycles. Finally, I'm setting the pixel color by sampling the texture in the U and V coordinate. And we're going to do the same for the bottom part of the triangle. Let's run the code. It looks like it's working, and the FPS is now about 1800. This is so satisfying, at least to me. But there is a small problem. The texture looks warped from certain angles. Oh yeah, the great memories of the original PlayStation games. While some tutorials will state that this can be fixed only using hardware acceleration, they are plain wrong, and I'll show you how to fix it now. This perspective issue comes from the fact that when the triangle is further away from the screen, the distance between 2 projected points becomes smaller. Let's see an example. Let's consider this top-down view of you, the screen, and the virtual 3D world behind it. If we would project this line on the screen, this would be the result. So far so good, but now let's project the center point of the line as well. This will fall right here. As I was expecting, the projected center doesn't fall in the center of the projected line. Like I said, it's because the right side of the line is further away from the screen and the left side is closer to the screen. This results in texture warping if we don't take it into account. To fix that, I'll add a third texture coordinate to the point3D structure called W, which by default will be 1. In engine base class, I'll copy that over whenever I transform the 3D point, except for apply perspective. In fact, right here, I'll transform all 3 texture coordinates the same way I do with the X and Y. Finally, when drawing the triangle, I make sure to calculate W the same way I do with U and V, as in calculating start and end, swapping, and calculating steps. In the end, when sampling the texture, I divide U and V by W. And that is it. Look at that, isn't that beautiful? I could watch this for hours. I'll just leave this here so we can enjoy it for a while. In the meantime, why don't you subscribe to this channel? I'll add the next episode soon, where we'll implement cameras, triangle clipping, lighting, and a lot more. Give me a thumbs up if you like the video, and I'll see you soon.